Good afternoon, students. Thank you very much for availing your time to watch this presentation for Mathematics 5. I am your tutor, Mrs. Loide Shikongo. Before we begin, as you are aware that our studies will now be online, assignments, doing assignments, examination, and so on. I know it's quite a challenge when it comes to mathematics, drawing graphs and all that, but I'm assuring you that the system is mathematical compatible. You'll be able to draw a graph, you'll be able to draw rough constructions, you'll be able to plot, especially when it comes to graphs and drawings. That is a very important topic in mathematics that you cannot skip, whether we are doing it online or not. You just have to be to familiarize yourself very well with the system. Do not wait until the last time where you are doing a last-minute rush to cover everything and to do the graph, and then you start complaining that why are we drawing graphs on computers? We don't know, while you did not even make an effort to familiarize yourself. And then you study all those icons. They are there. Even to draw graphs, you are able to. Please, and as I always say, if you have any problem, if you have any question, I'm always here to help you. Okay, now, as I said, I'm Loida Shikongo. That is my number, 081-2009-524. I'll prefer you sending me a WhatsApp if you are able to, like a picture. If you have a question, just take a picture of the question, then you send it. I'll get it and I'll come back to you if I'm not available online that moment. And also you can reach me on email, but yeah, I prefer WhatsApp much better, much more. Yeah, my email is loidemwetu@gmail.com, or you can reach me from 4:33 up to before 8 o'clock news. Thank you very much. Okay, to start with, welcome to this year's module of Mathematics 5. This is an interesting subject that has a universal application in the world, in our daily lives. So it's a subject with 6 units, and we are going to look at some of the contents, and I want you to pay very good attention. It's not everything that I only picked some challenging. I know it's not challenging to everyone, but according to my experience, most of the students, they really find this type really much challenging. Okay, the good thing about mathematics is that once you master the procedural understanding, you most definitely be able to answer most of the questions. Know the rules, know the steps, and all those things involved in mathematics. This is the subject that we have done from grade 1, and the reason why you chose it to be a you chose to be a mathematics teacher is because you like numbers. I hope you are not allergic to numbers. Okay, let's begin. Unit 1, it's on calculations about numbers, or calculations with numbers. As I said, mathematics it's about numbers. Backbone is numbers. You need to know the different types of numbers. It's sometimes, I don't want to say shocking, but yeah, it is shocking to see that some people don't know what even numbers are, odd numbers, prime numbers. Yeah, I don't want to make fun of it, but yeah, please just know the different types of numbers that we have to work with. Limits of accuracy, we are going to look a little bit on that, finding the upper and the lower bounds. Yeah, for the limits, it's not really much more detailed for your curriculum. Yeah, it's quite basic. number sequences, directed numbers, scale drawings, and calculations. We are also going to look at that. Money calculations, especially simple and compound interest, we are going to look at that. Length, mass, time, volume, capacity, area, and speed. We are going to look at how to calculate time duration, ratio, rate, proportion, estimation, and approximation. Estimation in most, especially, or approximation, that is where we need to round off either one decimal place or whole numbers or significant figures. Yeah, that is what is really much involved. And other parts like proportions, there is one part which is variations, that is very much important. And a presentation was done, I think 1 year back. Yeah, you can go on YouTube and just try to watch that video on variations that I've done, or you can call me, contact me if you have problems. Do not sit with problems. We are in this journey, we are in this together. I don't want to leave anybody behind because you failed your module. Please be free to contact and ask your questions. I'll never turn your back. Okay, number types and relationships. Types of numbers, we have real numbers, which are all the numbers that we use in mathematics, or the numbers that are on the number line. Imaginary numbers, those are numbers that do not exist. If you press them on your calculator, they will give you a math error. You will not get an answer there because it doesn't exist. Okay, integers, positive and negative whole numbers, like negative 0.5. My dear students, is not an integer. An integer is a whole number. Underline that. Directed numbers, the numbers with directions, positive or negative. Is it positive on the right, positive up, negative on the left, or negative down? So we should know this type of numbers. Even numbers from grade 1, even numbers, odd numbers, divided by 2 or cannot be divided by 2. I'm sorry for that. Should be divisible by 2, not 3. Prime numbers have only 2 factors. That number can only be divided by 1 and itself. We have composite numbers that has more than 2 factors. Natural numbers, these are numbers that you use for counting. Or counting numbers, these are the numbers that we use when we learn how to count. So they make a difference between natural numbers and counting numbers. Okay. Square numbers is the product when you multiply the number by itself. You should know those square numbers. 1, 4, 9, 16, the list goes on. Cubic numbers, the number or the result when you multiply the number by itself 3 times. 1, 8, 27, 64, the list goes on. Rational numbers, these are the numbers that can be written as common fractions. You should know that all the whole numbers are rational number. Okay, irrational numbers cannot be written as a common fraction. Like if you press that number on the calculator, it will not change into a fraction. So then you know that this is irrational, or their decimals are unpredictable. You cannot determine what will be the next decimal point, and so on. Okay, then we look at number types and relationships. We are going to look at computation with numbers. A factor. What are the factors? This looks simple, but these are some things that will really fail, whether it's in the examination or in the assignment. Okay, that's why I bring it up. A factor is a number that divides exactly into another number. Multiples. These are just different multiplication timetables. Now, there are those students who confuse factors and multiples. Can you remember those multiplication timetables at the back of your books when you were in primary or so? Those are multiples. Okay, don't confuse them. And when you talk about factors, we talk about division. Which number can divide this number without any reminder? If a number can divide exactly, then we can say that is a factor of that number. Standard form. a special way of writing very big or very small numbers. You should also be aware of that. Estimation and approximate calculation of a value. That means rounded to place values, decimal places, significant figures, limits of accuracy. All those things are under estimation and approximation. Okay, now as I said, I want us to look at a little bit on limits of accuracy, or other words is bounds of accuracy. What was the number before it was rounded off? If it's now said find the upper and the lower limit of 90 rounded to the nearest 10, meaning that number was not originally 90. 90 became 90 after it was rounded off. Now we want to see which number was it before it became 90. That is where we talk about upper and lower limits. There are possible values. The exact value could have been, before it became 90, it could be 89, 87, 86, 85, any number that can round to 90. Give those possible values. Now the lower limit or the lower bound, that is the smallest value that will round up to the estimated value. What is the smallest value that can round to 90? And then upper limit, that is the smallest value that will round up to the next estimated value. After 90, what is the next number? Is it 91 or is it 90.8, 90.1? So then the upper limit is now the smallest value that can round to the next number after 90. So that is a difference that I want you to to find. And then let's look at the upper and the lower limits of the following numbers. We have 80 kilometers to the nearest kilometer. Now there are those who don't really know how to find the upper and the lower limits. Now it said 80 kilometer to the nearest kilometer. Okay, that in most cases it is written like that. Now we usually use this word nearest. If it's nearest kilometer, how many kilometers can you see there? It's only 1 kilometer. If I mean 10 kilometer, then I could say 10 kilometer, but in nearest kilometer it's just 1 kilometer. So then we take this 1, we always divide it by 2. 1 divided by 2, then we get 0.5. Now to find the lower bound, we abbreviate it with LB, we minus. That would be 80 minus 0.5, which will give us 79.5. Okay, and then upper bound, that will be 80 plus 0.5, that will give us 80.5. Okay, so then this is a very important step that you should know. Which number, ask yourself, which number should I divide by 2? Once you get that number, and you should know how to get that number, because this number can change. It's not always 1, it's not always 10, it's not always 2, it's not 100. It depends on how the number was rounded off, and that is what you need to know. Practice more on finding or knowing which number we should divide by 2, so that we get our number that we have to add or subtract to get the upper and the lower bound. Okay, the next one I have, this was A. There I have B, which said, how about if I said find the lower and upper bound of 144 to the nearest whole number. Again, nearest whole number. I hope you know what a whole number is. A whole, a complete thing. A full revolution is 1. We still here, we are going to divide with 1. 1 divided by 2, it will give us 0.5. To get the upper bound, that will be 144 plus 0.5. Then you get your answer. And then to get the lower bound, that will be 144 minus 0.5. Then you get your answer. Okay? Then the next one, C. How about if it said the number is 258 rounded to 3 significant figures? Find the upper and the lower bound. Now, when it comes to significant, it's not exact. It doesn't mean that I have to take 3 and divide by 2. I have to go back to my number. This is 258. Then identify the third significant. Which one is your third significant here? So then from the number here, 2 is my first significant, 5 is my second significant, 8 is the third significant. Now, what is the placeholder? What is the placeholder of 8? Placeholder we mean is 8 a unit, a tenth, 100, 1,000, a tenth, and so on. Now if you look at 8, my 8 is a unit. A unit is regarded as a 1. That's why in this case here, we are going to use 1. 1, then we divide it by 2, then we get 0.5. Okay, 0.5, then we take 258 plus 0.5 if you want to get your upper bound, and you take 258 minus 0.5 if you want to find the lower bound. Okay, so for significant, we look at the placeholder of that number. Identify it first. If it was maybe to 2 significant in this case, and my second is significant is 5. What is the placeholder of this 5? 5, this is a unit, 5 is a 10. Therefore, I'm going to use 10, then I divide it by 2. I'm going to add or subtract 5 to get my upper and my lower bound. Alright, if it was maybe 258 to 1 significant figure, in this case my first significant is 2. So then you take 2. What is the placeholder of 2? This is a unit, this is a 10, this is 100. Alright, 2 hold a place of 100. Therefore, we are going to use 100 divide by 2. Then we get 50. 50 is the number that you are either going to add or subtract to get the upper and the lower bound. I think on significant figures there, it's clear. Alright, then the last one here, let me just put it here. D, I have 20.67 to 1 decimal place. Again, when it comes to decimal places, some of you confused, which number should I divide by 2? So, decimal places also, we use placeholders of numbers. Okay, but then decimal places, you should know that we are now talking about numbers after the comma. Numbers after the decimal point are fractions, whereby the first one is 0.1, 0.01, 0.001, 0.0001. Like if it's 1 decimal place, we divide by 0.1. We take 0.1 and divide it by 2. If it's 2 decimal place, then we use 0.01 and so on. Okay, now for this number 20.67 to 1 decimal place. 1 decimal place, this is my first decimal. 6 is my first decimal. As I said, decimal places, we follow this. Okay, so if it's 1 decimal place, we use 0.1. 0.1 divided by 2, we always divide it by 2. Then we get 0.05, right? Okay, this is the number that you have to add or subtract from 20.67 to get the upper and the lower bound. If it was 2 decimal places, like 7 in this case, we use 0.01 divide by 2. You get your answer, you add it or subtract it to get your upper and your lower bound. Alright, I think when it comes to the limits of accuracy, it's quite clear. If it's not clear, I'm always available for questions and for further help. Alright, then the next thing is powers of numbers. There are cases where you will be given like a list of numbers, like that is usually the first question. Like in the list of numbers, we have numbers like 1, 8, 7, 4, etc. Then it say from the list write a power of, or choose the power of 2. For example, what do you do to get these numbers? To choose the power of 2. Now what is the power of 2? For a power of 2, for example, is a number of the form 2 power n, where n is an integer. That is the result of exponential with number 2 as the base and the integer as an exponent. So then you want to find from this number which one, 2 power what, to give you either 1, 8, 7, which one it's a power of 2 here. Now if you're talking about power of 2, we take 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, etc. 2 power 0 is 1. Meaning 1, if 1 is in the list, 1 is the power of 2. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. So you can, and so on. So you can see that 1, 8, and 4, they are all powers of 2. Powers of 3, you start power 3 power 0, 3 power 1, 3 power 2, 3 power 3. The answer you get is a power of that number. 4 power 0, 4 power 1, 4 power 2, 4 power 3, etc. That is how we identify the powers of different numbers. Okay. Now, let's move on to calculation of time duration. Duration of an activity is the difference between the starting time and the finishing time. Okay? We can calculate the duration of an activity if we know the starting and the finishing time, or vice versa. Okay? For example, if the morning assembly in a school begins at 8 o'clock and finish at 8:25, the duration of the assembly is the difference of the finishing time and the starting time. Okay, so then 8:25 minus 8 o'clock, so then we know that the assembly was or is 25 minutes long. If we know the starting time and the duration of the activity, we can calculate the finishing time of the activity. So then we have 3 things involved here. You can be given the starting time and the finishing time to get the duration, or you can be given the starting time, the duration to get the finishing time, or you can be given the finishing time and the duration to find the starting time. So then those 3 things, they always play around with each other. Okay, now let's look at this example. Rita left for Naira's house at 7:30 p.m. She reached Naira's house at 8:10 p.m. How long did it take her on the way? How long was her journey to Naira's house? So then if the starting time is 7:30 and the finishing time is 8:10, what is the duration between 7? How many minutes are there between 7:30 and 8:10? So we know that is what? is 40 minutes. That's quite easy to get. But there are some other complex question where the duration is so long, like between 5 a.m. and 7 p.m. Now you see how many hours are there. Okay, but it's not, as long as you know the difference between a.m. and p.m. I don't think it will be much difficult. Let's look at another example. Uma's flight took off from New Delhi at 11:15 in the morning. That is 11:15 a.m. When we talk about a.m., what time of the day are we talking about? When it arrived in Mumbai, her watch read, it was reading 1:32 in the afternoon, or 1:32 p.m. How long was the flight? So imagine now from 11:15 in the morning to 1:32 in the afternoon. How many hours and how many minutes are there? Okay, this one calculated it already. It was 2 hours 17 minutes. But how? So then if we take 11 a.m. or 11:15 to 1:32, I can use 13:32. Okay, how many hours and how many minutes are there? For me, I like working from 11:15. At what time will an hour clock? 11:15 to 12:15 is 1 hour. There is 1 hour here. From 12:15 to 13:15, it's another hour here. Now, I want how long, how many minutes are there between 13:32 and 13:15? How many minutes are there now? From 13:15 to 13:32. 32 minus 15 will give us what? To give us 17 minutes. So then we have 1 hour, 2 hours, and 17 minutes, meaning her flight took 2 hours and 17 minutes. Okay, so you can work it out from an hour to an hour. That is quite an easy way to get the duration. The next question. Eddie left his home for school at 6:30 a.m. He reached school after 40 minutes. At what time did he reach school? So you can see that you are having a starting time and the duration to get the finishing time. What time did she get, or did he reach school? Okay, 30 minutes from 6:30. If you add 40 minutes, 6:30, we have another 30 minutes, then you have 7 o'clock. From 7, you add extra 10 minutes to make 40 minutes, 30, remember the first 30. Then if you add the 10 minutes, then you mean that he reached home at 7:10. That was quite very easy. Then it's in number 5. On May 1st, the sun rose at 5:05 a.m. and set at 7:45 p.m. How long could the sun be seen? Again, this one, how long, that it's time duration there. We're talking about the duration between the starting time and the finishing time. Okay, now if you work it out, this is quite long. You can work it out from hour to hour. From 5:05 to 6:05, that is 1 hour. 6:05 to 7:05 is another hour. 7:05 to 8:05, 8:05 to 9 hours. Then you see how many hours. Then the last minute, the last one, you work out the minutes now. How many minutes? Because in case you did not find a full hour now, it was how many minutes then? Okay, so then it was worked out as 14 hours and 40 minutes. All right, another question is, Sharon is unwell and the doctor advised her to drink glucose after every 45 minutes. If Sharon drank a glass of glucose at 7:30 a.m., what time will she take the next 2 glasses of glucose? That is another way of asking this type of questions. What is the next time? After, is it after 45 minutes? How do you do that? If it's 7:30, from 7:30 add 45 minutes. How many minutes? From 7:30 add 45 minutes. From the next time now, add 45 minutes. Then you see, this is the time that you take. This is the time that you take. Then the next class. Okay, then according to that, you will take the class at 8:15 a.m. and another one at 9 a.m. All right. Then we move on to scale drawings and calculations. Now, when it comes to scale drawing, I'll just pinpoint the most important thing here. I want you to know the distance on the map in connection with the distance in reality. These are the only two things that we work with. You know, the maps are scaled so that they can fit on paper. They are reduced so that they can fit on paper. Calculating the scale distance using the actual distance. If the scale is 1 to x, then divide the actual distance by x to calculate the map distance. Scale factors are used to accurately scale up or down an image. Scale drawings will come with a key or a scale factor that tells you what a dimension in the drawing is equal to in real life. Like 1 centimeter to 100 meter, that means 1 centimeter on the map represent 100 meter in reality. Or 1 to 10,000, 1 centimeter on the map represent 10,000 centimeters in reality. Or you see that line that represent the distance between 2 points. Now when it comes to drawing the distance or to calculate the distance, let's look at this example. The scale of a map is 1 centimeter to or 1 centimeter is 200 meters. Okay, so one thing that you should note that the centimeters or the question, you should be able to identify which one represent the distance on the map and which one represent the distance in reality. So that according to this question, it's 1 centimeter on the map represent 200 meter in reality. Now, if the distance between the two hotels on the map is on the map, it say on the map is 3.93 centimeter. What is the distance in reality? You can cross multiply that and work out. So the 9 centimeter times 200 meter, then you get your answer already in meter, because this is 3.9 centimeter per meter in on the map. Okay, that's it. You multiply and then you get your distance in meters. Now, in a town, the main shopping center is situated this is 650, I'm sorry for a double written number, 650 meters away from the bus station. A map is drawn using the scale of 1 centimeter representing 250 meters. Calculate the distance between the shopping center and the bus station on the map. Now you are calculating the distance on the map. So then sometimes you should know which one are you calculating. If it's the distance on the map or the real in reality. So then every centimeter equals 250 meters. Therefore you need to divide 650 by 250 to find the distance between the shopping center and the bus station. That means 650 divided by 250, it will give us 2.6 centimeters. So then you should know how to work out with these scale drawings very well. Thank you. We are moving on to money, simple interest and compound interest. We are not going to go in much detail here, but I'm just going to emphasize on how well you can answer these two types of questions. You should know what simple interest is and what compound interest is. What are the formulas? What is the question asking you to work out? Is it the interest or is it the total amount? Simple interest is calculated on the principal or original amount of a loan. Compound interest is calculated on the principal amount and the accumulated interest on previous period, and thus can be regarded as interest on interest. That is compound interest now. Simple interest is paid or received over a certain period, which is fixed percentage of the principal amount, but compound interest accrues and is added to the accumulated interest of previous periods included, or interest on interest. So then I have two formulas here for simple interest and for compound interest. Interest principal times rate times time. Rate is a percentage divided by 100. Please don't forget that. And the compound interest, we take principal, then you multiply it with 1 plus the interest power the number of years. Okay, so then you should know what is the question asking, and so on. Let's look at these questions. We are not going to work them out, but what is the question asking? What is it you are given? If you borrow 3,000 at 14% simple, underline this is a simple interest question for 10 months. This is just months. Whenever the period is given in months, you must always divide those 10 months by 12. How much will you owe in 10 months? How much interest will you pay? This is the interest you are calculating, not the whole amount that you pay back. Suppose you invest 25,000 over a period of 4 years. If money is compounded, you can see that word compound. This is a compound interest. So then fix, or you're thinking on compound interest only at the rate of 8%. What interest? Again, what interest? Not the whole amount, but the interest that you receive. Find the amount due on a loan of 6,000 at 15.75% interest after 2 years. Interest, if they did not specify compound or simple, if it just says that, like this question just say interest, you should know that you have to work on simple interest. All right, then the other thing that you should work on or be careful about is reverse percentage. How do we work with finding the original quantity? How do we work back to 100%? First, find out whether you need to either add or subtract the percentage given in the problem from 100% to determine what percentage we have to work straight. You need to start with 100%. Now, in this case, there's a simple question. We always put 100 on top, divided by whatever percentage that you have worked out, times the original amount, or the given value, because you are working the original, right? So then take 100, because that is what you need. What was the value before a sale or before the price went up? What was the amount before that? Okay, there's a question here. Let's look at that question. There has been a 10% rise in prices in Markel's local coffee shop, and then the cappuccino now cost $22.75. How much did it cost before the increase? So we should always, it's a rise, you add 100 plus 10%, it will give us 110. Once you get this number, then you go to your formula. Take 100, divide with 110 times that value of $22.75. Then you see how much was it. Okay, so then that is how we work out that. Question 3. In a box, 15% of the fruits are apples. If there are 54 apples, find the number of fruits in the box. So in this case, it did not say rise, profit, loss. This is straight. So then take 100, divide it with 15. Always take the 100 up if you want to do reverse percentage. Then times 54. If you work out that, then it will give us the number of all the apples in the box. There are other different methods that you can use. Ratio, if 15% represent 54 apples, 100% represent what? You can work that, okay, and get your answer still, because 100 represent the whole box. Okay, thank you. Then the next thing on algebra, that is where you mostly do not do well much. Algebra, that is a generalized version of arithmetic that uses variables, letters, to stand for unspecified numbers. Its purpose is to solve algebraic equations or systems of equations. Now we know how to simplify. We add, subtract, divide, multiply, linear equations, making the subject of the formula, laws of indices, polynomials, that's finding the quotient and remainder, linear inequalities, and so on. All these things were presented in previous previous year's presentations. So then if there's something that is troubling you, especially when you come to finding the quotient and remainder, please contact me so I can help you out. Linear inequalities, laws of indices, whereby logarithms is also involved somehow, somewhere there. So then you should know how to work with all these things. How to work with simultaneous equations, solve simultaneous equation, or equation with fractions, brackets, and so on. Making the subject of the formula. I want you, when it comes to algebra, this is the backbone, so to say, of mathematics. Okay, and there is one finding the quotient of remainder and remainder here when it comes to logarithms. There are two methods. We have a long division method and a synthetic division method. Again, I want you to go and read and see which one you can apply, which one do you understand much better when it comes to finding the quotient and remainder. Solving simultaneous equation, we have two methods: elimination and substitution. Practice makes perfect. You need to know how to solve this. 4 marks or 3 marks, they are just too many. They are a lot for to be lost. But it's not something which is difficult, okay? All right. But as I said, questions, please, you are welcome. Factorizing. When it comes to factorizing, we have completing the square, difference between two squares, complex quadratics, simple quadratics, splitting in single brackets, that is grouping, and common factor. You should know which method work for which. For example, if I'm having factorize 2x squared plus 6x plus 12, for example, which method can you use to factorize this? Is it taking out the common factor? Can it work? Is it grouping? Is it difference between two squares? Is it quadratic trinomials, whether it's simple or complex? Okay, this is a complex quadratic trinomial where we have a number here. If I'm having x squared plus 6x plus 10, let me say plus 15 or 12, this is a simple quadratic trinomial because we don't have a number here. Okay, if I have an expression y squared minus 9, which method can you use? That is difference between two squares. So you should know which method can you use for what. Then we have logarithms. That is something, another part of mathematics that most of you don't do well at all. Logarithms, you should know how to fix or to switch between logarithm and indices. They are mother and a daughter. In this index form, logarithmic form, if I have 2 power 6 is equal to 64, then in logarithm form I said log 2 base 64 equals 6. Okay, log form 2 raised to what power to give 60. So then in this case, you in logarithm you want to find which number, was raised to base 2 to give 64. 2 power what to give us 64? It's only 2 power 6 that to give us 64. Therefore, 6 is the answer there. You should know how to write or change numbers written in index notation form to a logarithmic form and vice versa. You should know the logarithmic laws, product, power law, and the quotient law, and how to work with them to solve problems. So then these are the two things: exponent rules or laws of indices with logarithmic rules. Okay, in exponents we know that if the bases are the same and you are multiplying, you add the indices. This is the thing. If you are multiplying the two logs, is the same as adding the two logs. Now this will come in when you are given a log question to either expand it or to write it in as one single log. So then you should know these properties of exponent or logarithm rules and how they apply to each other. In conclusion, my dear students, practice and practice more often. As I said in the first time in the introduction, if you happen to know the procedures, the steps involved, the formulas, then when it comes to calculating to get the answer, it won't be that much difficult anymore. You should know the formulas, you should know the steps, you should know the rules. Know what to do when the question asks to factorize. I don't want to see you simplifying why I want you to factorize and so on. Solve, simplify, draw, prove, show that, those type of questions. The whole syllabus is covered in the question paper. All the units are equally important. Whether they are presented here or not, please study everything. Read and understand the questions carefully before you answer. And if a graph is involved, please, before you do start with today's assignment and submit tomorrow, make sure start on time. Please acquaint yourself with the system so that you know where to go when you are when you need to plot or you need to draw a graph. It's not difficult. I know you can do it. I trust you. I wish you all the best with your studies. Stay safe and thank you very much.